Now this illustration deals with calculating the available short circuit current at the terminals of the service equipment. Now 110.10, as previously stated of the NEC, would allow anything that is in the available short circuit current path to be used to reduce the available short circuit current at the point of delivery. Now, another thing that was added in just a couple cycles back or so, in 110.10, a statement was made that a little bit of damage might occur during a short circuit condition. And this was to kind of protect the designer, the installer, or the electrician by the 110.10, used to say that you were protected from damage. And that's the way a lot of folks read it. So they wanted to make it clear, no, you could have a little damage, and you know, in the eyes of the NEC, a little damage is when it can be repaired, replaced with a retrofit kit or with the appropriate circuit breaker contacts or whatever, but the equipment's not destroyed in any way that it has to be completely replaced, so to speak. Now, let's review this method one. Now, the first step is to determine what is the available short circuit at the transformer. So you see in the step one, the FLC in amps is the formula kVA times 1,000 to get volt amps, divided by the voltage times the square root of 3. So the next step in the formula is taking 200 kVA, rated of the transformer, times 1,000, divided by the voltage, 480 times the square root of 3, and then we derive the amps of 241 amps. That's the output of the transformer. Now we have to figure out what would be the available short circuit current at the transformer based upon the impedance of the transformer, step two. So the available short circuit current at the transformer is taking the 241 amps, the full load current rating in amps of the transformer, and dividing it by 1.5%, which converts to 0.015. And when we do our math there, we come up with 16,067. 16,667 amps at the transformer. Now we're going to calculate the F factor using the manufacturer's table of C values, and that would be in table B of the Stallcup's electrical design book, but it's also in the busman handbook that busman puts out. Now notice the F factor is taking 1.732, the square root of 3, times the length of the run from the transformer to the main and the switchgear, times the amps. So that's divided by the C factor that we find in the table of C values in the design book, or go to the busman book, and it's line to line based upon the conductors being pulled through metal conduit. Now, taking 1.732, the square root of 3, times 100 foot, the length of the run, times 16,067 amps, the available short circuit current at the transformer, divide that by 16,483, which is the constant we select from the C values based upon a 250 kc mil being pulled through rigid metal conduit, times 480 volt. Now when the math is done, the F factor is 0.352 for that length. For those size conductors, pull through rigid metal conduit, say. Now, step 4, we're finding M. M is equal to 1 divided by 1 plus the F factor that we found in step 3. Now, when we do the math, we come up with an M factor of 0.740. Now, to determine what the available short circuit current would be at the service equipment, we take the 16,067 times 0.740, and the approximate available short circuit current at the service equipment is 11,890 amps. So we could use, say, a 20 KA rated system. If you could purchase it, you could use a 15 KA system, and that would handle the available short circuit current. Now notice, this can be done by an electrician in the field. And if you go online, you order the Stallcup's electrical design book, those tables are there. You can just put it on your phone or on your computer, and you can go in and figure this where it's not already figured and on the equipment for you when you arrive to perform the repair, the maintenance, or find out whatever type of problem that may be present, and you're trying to troubleshoot it and clear it up so everything is in a safe and reliable operating condition. So this figure 6-34B is showing method 1. Now we're moving on to method 2.